The grand piano. In the right hands, this instrument can lift our spirits and transform our mood. Like a purring classic sports car, beneath the sleek exterior lies a machine of astonishing power and complexity. More than 12,000 components fit together inside 17 layers of hard maple wood. 243 tightly wound strings exert 20 tons of tension on the cast iron frame. 88 keys, each made of more than 50 pieces, strike the strings for just 0.02 of a second. The solid wood soundboard resonates the notes to over 100 decibels, as loud as a jackhammer. This king of instruments is so robust, it can produce the perfect tone every day for over 100 years. The piano's outer rim helps resist the incredible 20 tons of tension from 243 strings. At this 140-year-old factory in New York, it takes more than 200 craftspeople almost an entire year to build a concert grand piano. Workers here know the secret to a successful rim. It takes 6 people to bend its curved shape. Workers must form the rim from a single stretch of wood to give maximum strength and superior sound quality.
Since it's 17 laminations and 20 feet long, is one of the hardest rims to bend.
Lorenzo runs the rim bending crew. First, they coat the 17 layers of maple with glue. Then Lorenzo's crew has just 20 minutes to force the 8-centimeter stack of strips into a piano shape. Get this wrong, and the rim is wrecked. The crew creating the grand piano's rim has just 20 minutes to force 3 curves into this 6-meter length of wood.
The guys are closing it up with the wrenches, we're gonna use a ratchet wrench to close it at 250 pounds of torque per square inch.
The team tighten 23 clamping cylinders. They hold back nearly 500 kilos of tension in the bent rim.
So you're gonna hear the wrench go click. Once he hears the click, we're done.
Once the final clamp locks on, it takes 24 hours for the glue to set. Once set, workers line up the rim alongside 250 others in the conditioning room. 3 months in this hot room gradually draws the moisture out of the wood, transforming the 17 layers into a single solid structure, helping the rim withstand the incredible tension pulling across the piano. For a loud note, the piano's strings need to be struck hard. But the pianist's fingers would soon tire if they had to generate all the hitting power. How does a light touch of a key hit the strings with formidable force? More than 4,000 pieces link the keys to the strings. The key seesaws deep into the piano, lifting a set of intricate levers. These amplify the motion, so the hammer moves 5 times the distance at 5 times the speed, transforming the touch of a finger to the power of a punch. This intricate design has magnified the pianist's movements for centuries. The piano has a built-in amplifier to make sure that each note really has the power to be heard above a full orchestra. Hidden beneath the strings, the soundboard raises the volume.
This is what gives us the sound of the piano. This is the main component. This is the heart and soul of the piano.
Henry gives every soundboard maximum volume. An extremely subtle curve across the wood gives it an amplifying boost. This crown magnifies vibrations from the strings, just like the cone of a megaphone. It's made by the hot, wet air in this room.
So we're adding moisture to the board itself. Once we start adding that moisture, the board will naturally crown. It'll naturally develop that arc in it that we're looking for.
Now it has its crown. A craftsman places the bowed board inside the piano rim. But pure volume isn't enough. The pianist needs control over the dynamics of every note. Each can be abrupt and muted, or stretch out over several seconds. The source of this variation rests in a set of pedals just beneath the pianist's feet. The pedals drive levers into the heart of the piano. They move hundreds of components with one touch. The sustain pedal lifts woolen dampers, so the strings' vibrations linger. The soft pedal shifts 4,000 parts 2 millimeters to the right, so the hammers hit just 2 strings rather than 3. With this intricate system, just one tap of the foot creates moving music. Thankfully, pianists never need to think about the complex mechanisms that create each note. But they do rely on every key reacting in exactly the same way. This is the balancing room. The craftspeople here make sure every one of the 88 seesawing keys raises its hammer with the exact same touch.
So it can't come up too fast and it can't come up too slow. They have to come up just right.
Gwen makes sure every key is perfectly poised. First, she patiently positions different weights on each note to find the sweet spot where the key will play with minimal force.
This is the small I put here. It's not moving. It's not doing anything, so I have to put the large, you see? But the large is fast, so you have to move it to the right position to make it balance good, you see? That's what you want. So I'm going to mark the key when it gives me the right balance.
Once she's happy, Gwen marks the position where a matching weight will be drilled into the key. Her careful work makes sure every hammer lifts with the same force from a pianist's finger. Another stage complete in the 11-month process of crafting the ultimate instrument. 300 years of fine-tuning has generated this mechanical marvel. The piano, the perfect marriage of art and engineering.